Hello everyone and welcome to the introduction to the general toothing algorithm module. This is a new module for Gearotic and has changed a little bit from what you may have seen in previous versions as it started to build. Primarily the DXF button has been removed. DXFs will reappear as a way for the user to plug in some gear creation options of their own. So let's take a look at what's on the GTA. It is basically a gear cooking kitchen. It's you select the recipe and come up with a gear that you would like to use. And you'll see from the technology we're using that it's easily expandable for future use. So on the screen I have two elliptical gears, two elliptical pitch lines. The lines that you see are the actual pitch lines of the gear that you'll be creating. So the gears will extend from the pitch line by the addendum and be behind the pitch line by the dedendum. You can select your orders just like on the previous elliptical module that we have. You can select orders up to 9. I doubt very much anybody would be building a gear larger than an elliptical order of 9, so I've kind of limited you there. At the top of the screen you can see, firstly, you can enter an eccentricity for the elliptical shape. This pretty much follows the previous elliptical screen. But now you can also have a modified elliptical which changes the symmetry of the gear. So the gear is no longer symmetrical top to bottom. And this creates a lot of challenges in terms of meshing two gears together. You can see that these gears, while they do mesh, they don't mesh at a 90-degree angle to each other. So everything gets a little bit strange when it comes to seeing exactly how they'll operate in terms of speed. There are two ways to tooth shapes in the new module. You can tooth them on a involute shaper, and you can see a picture of the shaper down here at the bottom of the screen. Or you can tooth them with a hypocycloidic shaper, and more shapers will be coming. And in terms of DXFs, what I'm going to try to do is allow a person to draw a shaper of their own. That would pretty much allow us to encompass any type of gear which would end up being a legal gear that would run properly. You have several selections to control your shaper. You can control the tooth count, and you can see it changes there. Or you can control the pitch line on it. And we'll go into that in a little bit more depth in a moment. Let's talk about our shapes just a touch more. As I said, I have modified ellipticals on the screen, and a modification coefficient controls the amount of asymmetry that exists on these ellipticals. Typically, a modification coefficient would run from 1 forward to maybe 2. You can get strange shapes if you go as high as 3 or 4 on your modification coefficient, but you at all times have to be concerned about whether or not you're making too much of a divot in a gear. A concavity in a gear makes it very difficult to tooth, and the shape of the shaper begins to take a whole lot more importance on how we can roll around that curve. Let's take a look at toothing something like this as an example. Let's switch to a hypocycloidic shaper, and you can see it changes at the bottom. And I'm going to hit tooth wheel. And before I do, take note of these 3 buttons up above here. There's low, medium, and high resolution. In order to give you a solution that would give you teeth in a viable amount of time, I want you to be able to play with it, but then in the end be able to generate really good teeth. So I've given you low, medium, and high resolution, and that controls the amount of time it'll take to tooth. So I'm on low resolution. Let's tooth a wheel. And you can see it takes about 5 seconds. But your teeth may not be of the highest quality. Here you can see that they're actually not that bad. And we'll tooth the pinion. Gearotic motion is basically rolling this shaper around these shapes and creating the teeth from the shaper. That's the way gears are actually made in a factory, and the theory here is that if we make them like you would in a factory and do the same to both gears, they should end up quite meshable. And indeed, most of the time they are. You can see here that this tooth is hitting a squared off portion. That didn't have to be squared off, because if we watch it rotate, it actually rotates in and misses a little bit. This is due to the shaper perhaps being a little bit too large to fit into this concave section of the curve. Let me regenerate. Hitting regenerate will take you back to your pitch lines. This curve here is a little bit too sharp for this shaper to be able to fit it. So you can play with things such as lowering the tooth count of your shaper, and if I take it down to like a 6-tooth count, you can try to shape it again and see if your shaper does a better job on it. Takes about 5 seconds, and as you can see, we did get a better shape by having a smaller shaper. So this goes to show that playing with the shaper parameters can sometimes help you when you're trying to tooth a very odd shape. And these two gears appear to mesh much better. A little note about the meshing on these screens. On all the previous screens, we're using direct formulas to compute the gears. This makes it pretty easy to figure out which angles the gears will attach to each other in. In this type of problem with these shapes of gears, it's more of a calculus problem, which means that the answers are related to a lot of derivatives, which means I can't always give you an exact answer for the rotation. So these simulations may not be spot on in terms of how they're actually going to fit for you. So you want to take a good look at the teeth, and you can see that we appear to be overriding ourselves a little bit here. It's not much of an amount. When we're zoomed in here, the scale is quite large. These gears would probably work fine. And you may just have to add a little bit of backlash in order to get them to fit. But when we zoom in on the teeth, you can see that they're quite jagged. They're not very pretty at all. That has to do with the fact that we're in low resolution. If we leave it here and switch to medium resolution and do the exact same toothing, you can see it takes a little bit longer for them to tooth. Somewhere around 10 seconds on medium, and it could take you as high as 15 to 20 seconds on high. This is why you have options to switch the resolution so that you don't have to wait quite as long. As you can see now on medium, the resolution is getting much better, and on high it will be near perfect. Medium resolution, if you were to cut it, would probably run fine as well, however, but your tool may jerk around a bit as it cuts it. And personally, I'm not real thrilled with the quality of that one. So let's go high and see what a high resolution does for us with this particular shaper. And this is why I refer to this page as more of a kitchen. You're going to have to play with shaper parameters, resolutions, and perhaps profile shifting on the shaper in order to create teeth that will do you for the job that you want to have done. As this develops, we'll look at ways of giving you even higher resolution, although it could take 4 or 5 minutes to do gears at the very highest resolutions. I'm going to leave that up to the users to tell me how they, in feedback, to tell me how this works out for them before I decide exactly how much of a time delay would be appropriate for people who want particular teeth. So this is the high resolution run with a 6-tooth shaper. It's much better, although there's still some jerkiness here that's somewhere around the area of about 1/5 of a millimeter. You can see when we zoom out, you begin to lose focus of those. So if you were cutting these gears to actual size, they would be around that size, which means the teeth are actually pretty good. They're certainly good for the decorative purpose that gears such as this are normally used for. The roughness that we've seen in the images, a lot of that has to do with the fact that we're in a very turbulent area of the gear. Right where that divot is in the gear is what creates these odd shapes. As you get away from the divots and into clearer portions of the gear, you can see that the teeth get much cleaner as you go. A lot depends on the size of your gear and the number of teeth in terms of the quality that you're going to get on that particular gear. Also, the number of teeth in your shaper can be very important. Let's switch back to an involute gear. Let's lower that modification coefficient back down to something reasonable, say 1.8 or so. And that gives us odd-shaped gears, which is something that's usually more appropriate to what people would want. We'll do an involute cutter this time. 8-tooth involute cutter, standard pitch line, and see what we get for teeth. I left it on high, And this kind of shows you why you should switch it to low when you're playing around, because rather than have to wait a long time to see approximately what the gears would look like, you'd be better off on low resolution. And there's our gears, and as you can see, they're pretty good involutes actually. Being high resolution, it did a fairly good job with those. Let's switch to low resolution and tooth the same one so you can see the difference on the involute cutters. Still a pretty good job, although we're getting jerkiness and roughness in the teeth. I wouldn't try cutting them from low res. I would probably only cut on the high res option. We can tooth the pinion. And you can see that these gears would rotate together quite well. Sign that an elliptical has been properly toothed is that the teeth are quite often asymmetrical, and as you can see, these teeth are different on one side than they are on the other, which kind of shows they're following the right formulas. One more thing that you should worry about is that you have the opportunity to shift your pitch profile. You can see that the teeth on these two gears are pretty much identical. Incidentally, these gears are different, although they look to be the same shape, and indeed the pitch lines are the same shape. The process of toothing necessitates that the gear be made differently. The teeth are not in the same position. They have been rolled almost like the teeth on a chainsaw rolls around the chainsaw blade. This allows the two gears to mesh up properly. Now, if we wanted the teeth on one gear to be stronger, we could do a profile shift and shift them up. Say a 40% shift on our shaper. Now you see three lines. The center line is the pitch line. The outer circle is where it's going to be placed on the pinion, and the inner circle is where the shaper will be pressed into the wheel. When you do a profile shift, you profile shift the opposite direction when you make a gear's pinion. And there's our gear from being pressed in too far on the pitch line, and when we tooth the pinion, it'll automatically take that into account and shift it the other direction, giving you a gear with wider teeth. And here at the bottom of the gear, you can see that the algorithm has screwed up and not connected the lines properly. When this happens to you, especially if you're on low resolution, go to a higher resolution and run the same toothing. The algorithm is young. It still has some lessons to be learned, and I'm catching all the time more and more items which make it cleaner and which take care of the aberrations like you just saw in the ordering. There's a bit of a science to ordering the points properly, and it'll develop over time. Let's tooth the pinion and see if we still mess up. Being that we're on high resolution, this takes a little while. The progress bar at the top will make two sweeps, and when it's done its second sweep, it's on the second sweep now, the tooth will appear. And there we go. You can see that because the profile is shifted, the teeth on one gear are smaller and the teeth on the other gear are wider. Profile shifting is often used to give strength, additional strength to a gear. You can see that we still got a mess up here though. It did not attach properly. Occasionally this will happen. You can try a higher or lower tooth count. It usually fixes it. And again, as the program develops, we'll take care of little oddities like that and do the best we can to remove everything. You can also do planetary gears in this version, elliptical planetaries. I would recommend not doing them modified until you get a little used to exactly how that all works. I'm going to switch to the hypocycloidal cutter for this one. Incidentally, the more teeth you have, the longer the toothing process can take. As you can see, the teeth are fairly well formed in there, so we'll form our pinion. I made a mistake when I made this by leaving the profile shift on in our shaper that you can see it's on because there's 3 circles on the shaper. So this will probably be a very odd looking gear if it works at all. And as you can see, there's no way that you could possibly, with this shift, allow these gears to run together. So you have to look very closely at what you've done to see whether or not things will work. So let's first of all shift this to low res. We'll turn off the profile shift by putting the shaper back on pitch, and then we'll try it again. Incidentally, it does you no good to really profile, change the shift profile on a round-toothed gear. It's really only applicable to an involute. And we'll tooth the pinion. And then we have 2 gears that probably would work fine. And you'll see that depending on the eccentricity that you've got on an elliptical planetary, your teeth may or may not fit in the corners. And as you can see on the meshing, this one is actually cutting off a bit. This would work fine if you just filed off a little bit on a tooth on a corner. For those that want decorative gears, little modifications like that probably aren't asking too much. But if you don't want it to hit those points, lower your eccentricity. Say we take it to a 0.5 to a 0.3, and we should get less of a cutoff and more of a square gear. And as you can see now, it fits much, much better. So again, we're back to the fact that this is a kitchen. You really have to select your recipe carefully and come up with the planetaries or gears that you want to make. As we add more shapers and so on, I'm sure it'll get more interesting in terms of what shapes we can make, and I may be able to come up with better ways to modify the primary shape of the ellipticals that we're offering. The teeth on this are actually better than the teeth on the original elliptical screen, and you'll find that you can create much more extreme ellipticals on this screen than you can on the original screen. I won't be taking away the original screen because I want to leave it there for legacy reasons of anybody that has built ellipticals using that screen. One point that I do want to mention before I end this video is I'm going to turn off the planetary and go back to 2 first-order gears. You must be aware of when your gears are the same and when they're not, because if the gears are identical, you could place a pinion on a pinion or a wheel on the project screen. If they're different, you shouldn't do that because they won't mesh. You'll remember on the original elliptical screens, you had to use an odd number of teeth, because if you used an even number of teeth, this would happen, where you'll notice on an even number of teeth, we have a hole at both 90-degree extremes of the gear, which means that if we had a hole, the identical gear over here, we'd have a hole on each side and we wouldn't be able to mesh. This doesn't happen with this module. Gearotic knows where the teeth lie and will move them around to fit. So you have to be aware that because we have an even number of teeth, these 2 gears are not identical gears. You will not be able to place a pinion on top of a pinion or a wheel on top of a wheel, only a wheel on a pinion. But if we go to a 21-tooth gear, odd number gear, you'll see that the 2 gears come out identical, and at that point you could place a pinion on a wheel or a wheel on a pinion. This can get a bit complex to observe when you're in higher order gears, so you'll need some playing with it to figure out exactly how in fact that'll work for you. Well, that's it for an introduction to the GTA. Enjoy playing with it. Release date should be around January 10th or so.